Okay, today is December 6, 2011. We're on lesson 7.2. We're going to do the third example first. The third example asks us to find the area of the industrial zone. The industrial zone is our highlighted area. Okay, so the area inside of this triangle. Now I don't know if you can see that parallel line there, but this line and this line are parallel to each other. Okay, so we're going to have to solve using similar triangles. All right, so first off, I'm going to name the triangles. Okay, we're going to call, let's say we'll call this one A, B. I'm going to call this point C. So it's going to have a common point, D and E. Sure. I am calling C the common point. Now what I'm going to need to do is I'm going to need to solve for these two triangles. Okay? So, in other words, we're going to have to find what the scale factor is between the triangles. Remember yesterday we talked about a triangle that had a ratio of 5 to 1. That means it would have a scale factor of 5 if it's going from the smaller one to the bigger one, or it would have a scale factor of a 5th if it was going from the bigger one to the smaller one. Okay, so we're going to have to find the scale factor between these two. Now, in order to figure out the area, we also have one more measurement. The other measurement I am missing is this. Now let's try to find some similarities between these triangles. Before I even start finding things, I know that the two angles on point C are opposite angles, so they're going to be equal to each other. Okay? And because these are parallel, I know that angle A, so I'm going to call it angle C, is equal to other angle C. Now, you know what? That doesn't make sense because that's obvious. So what I'm going to do is I'm going to name it the way the book would. We're going to call it angle ECD is equal to angle BCA, okay? Which means this angle here, A, where point A and D are, they're alternate angles, okay? So they're both going to be equal also. So we're going to have angle CAB is equal to angle CDE. Yeah, I would like to write it that way personally. The book writes them this way. And finally, angle E and B, also known as angle ABC, and angle CDE. CED are equal to each other. So we know these angles are all equal to each other because of our angle properties. I also need to figure out the scale factor between these two triangles. Okay? Does anyone know what the scale factor is? These angles are all the same, so we know they're what type of triangle? Yeah, we know they're going to be similar. The lengths are definitely not the same. So if they're similar triangles, how can I find the scale factor? Which parts of the triangles, essentially, which sides refer to each other, Josh? So side AB, so we have side AB and side ED. Okay, so side AB, this is where we're going to find our ratio, and side DE, do we call it? What are they going to be equal to? AB is the distance of 1 kilometer. DE is the distance of what? 3. So what this is saying is to go from side AB, the smaller triangle, to the larger triangle, we're going to have to multiply by 3 to go from the smaller to the larger. If I were to go from the larger triangle to the smaller triangle, I'd be dividing by 3. Okay, so depending which way we're going, our scale factor change. We could have a scale factor of K. That's what our scale factor is. We're going to use that variable to represent scale factor. K is equal to 3 in this case if we're going from triangle ABC to triangle CDE. Or the scale factor is a third if we're going from triangle CDE to triangle ABC. So remember, depending on whether we're shrinking, this is when we're going from a larger triangle to a smaller triangle. That's when we multiply by a number less than 1. Okay? So in this case, we multiply by K when it's less than 1. That means we're shrinking, going down in size. Okay? So if size is going down, K will be less than 1. If the size of the triangle is going up, that means our scale factor is going to be greater than 1. In that case, we have 3. Those are the two numbers we have. So when we multiply by a third, that means we're shrinking in size. We multiply by 3, that means we're growing in size. Okay? Now, I chose side A, B, and D, E is because they were the two corresponding sides that had measurements. If I chose in DC and CB, well, I didn't have any measurements, so I wouldn't have been able to find the scale factor. I used the two sides that I knew. And I set them up as a ratio. Ratios can be written as fractions. I chose to write it that way. It could have been written sideways. We could have compared it like this. I'll just do it on the side here. Side AB colon side DE, which would essentially been a ratio of 1 to 3, just like I had it in that fraction form. Okay? But remember, the question is asking us for the area of the industrial zone, which is our highlighted area. So what I'm going to actually do first, because we have a scale factor, is I'm going to find the area of the smaller triangle. Okay? When I find the area of the smaller triangle, I'm then going to use it to find the area of the larger one. So, I'm going to put a new page here. Okay, so we have our smaller triangle here. And remember the area of a triangle, and this would have been triangle ABC. So area of triangle ABC is equal to 1/2 times the base times the height, or base times height divided by 2. Same thing. Okay. Our base is 1, and our height is 1.4. So we're going to plug those in for our B and our H. We get 1/2 times 1 times 1.4. In this case, we get 1.4 divided by 2, 0.7. And now remember, this is kilometers squared. Okay, that squared part's really important when we're doing this scale factor. Remember our scale factors before, we'd only multiply by the number itself. Now, so that means the area of our smaller triangle is 0.7 kilometers squared. Now, what I need to do in order to find the area of the larger one, because it's in squared, okay, square kilometers, I'm actually going to have to square the scale factor, okay? So this actually refers to putting something to the power of 2. So the area of triangle CDE, which is the larger triangle we dealt with, is going to be times the scale factor, which is our K, squared, multiplied by the area of triangle ABC. Okay? Now we have all these things. Remember our scale factor K was 3, and we know the area of the other triangle. So in order to find the area of our larger triangle, I put the scale factor in, the number 3. I will square it, and then I'm going to multiply by the area of the smaller triangle. This will become 9 times 0.7 is equal to 6.3 kilometers squared. So in the end, the industrial size, or the industrial area, is 6.3 kilometers squared in terms of size. Now the tricky part of this question was realizing that we had to square the scale factor, okay? Because we multiplied by 2 dimensions to find it. Our answer was squared, so we're going to square our scale factor. The other way you could have gone about doing this, let's go back up. Let's look at both of them. Yeah, is we could have tried to find all the measurements of the larger one. Sorry. Here we go. So we could have found the measurements of the larger one by the scale factors. Okay. We could have made a right angle triangle using scale factors, and we could have used our, we don't actually have sine and coleslaw yet. Actually, this is the way we'd be doing it. Okay, so yeah, forgot about that. The height, we do have 1.4. We could have multiplied it by our scale factor of 3. We've got a new height of, anyone know? 4.2? Oh gosh. So, if we used our scale factor, our new height, I know that's not drawn straight, would have been 1.4 times our scale factor of 3, which was 4.2 kilometers. We could use that to find the area. So if we went back to our other page, our area of the larger triangle, which was triangle CDE, same style, times base times height. Our base in this one was 3 kilometers in the larger triangle, and the larger triangle's height, using our scale factor, was 4.2. We got a half, and 3 times 4.2, 2.1. Is that right? No, that can't be right. Did I type that in? 3 times 4.2. There you go, 12.6. That makes sense. 12.6 times a half or divided by 2 is 6.3 kilometers squared. You could use either method to solve this question. Page 347, 169, 22, and 22 and